Welcome to qnawire.
Okay, so this question is about wavelengths of everyday objects, and the relationship we need to remember is the deBroglie equation, and that's that wavelength is equal to Planck's constant, that's just a number, over, we're going to do mass times velocity. Okay, so this is the object in question, right? So what does this, what does this mean for the wavelength? Well, so basically wavelength is proportional to, so we're just going to kind of ignore these two for now, right? We're not interested in H, will never change because it's constant, and V just isn't as important as M. So we're saying wavelength is proportional to 1 over the mass of the object, okay? And the other thing is that the mass of macroscopic objects is freaking huge, right? Macroscopic is huge compared to quantum, right? So what we're saying is that we're getting wavelength is equal to Planck's constant over huge numbers times velocity. Okay, so what's this going to do to our wavelength if we're talking about macroscopic objects as compared to quantum objects? What happens to the wavelength? Well, the wavelength, as m increases, as m goes to infinity, then the wavelength is going to go to 0, right? So massive objects have really tiny wavelengths. So that's the first option. I'm assuming that it says the deBroglie wavelength is extremely small compared to the size of the object. So number 1, that one's the correct one.